Hello everyone, welcome to Integrated Math 2 with Mr. Schultz. Please make sure your information is in the top left and right hand corners, and let's begin. So, our notes for today are 2-3, specifically entitled Tests for Parallelograms. So, if quadrilateral has each pair of opposite sides parallel, then it is a parallelogram by definition. So, if both pairs of an opposite sides of the quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, so we're not even talking about, hey, look, it's parallel. We're saying, hey, look, these are congruent. These are congruent. Then it's a parallelogram. That's it. Now, once we determine that they are congruent, then we can be like, hey, look, these are parallel, and these are parallel, double. This is parallel with this line. This is parallel with that line. But first, they are congruent. Let's go on. If both pairs of opposite angles of the quadrilateral are congruent, you're like, all right, look, these are congruent, and these are congruent, then it's a parallelogram. Basically, we have just, from the last section, we said, hey, if it's a parallelogram, then the opposite angles are congruent. Well, now we're saying the converse. If the opposite angles are congruent, then it's a parallelogram. We are proving that this quadrilateral is a parallelogram. Let's go on. If the diagonals of the quadrilateral bisect each other, then the quadrilateral is a parallelogram. Well, from last section, we know that AO is congruent to OC. And we know that BO is congruent to OD. Now, we don't need to, say which ones, we can mix it up a little bit, like BO is congruent to DO, so that's fine. But if they're congruent, then it's a parallelogram, because a parallelogram, the diagonals bisect each other. Let's go on. Now, this last one, if one pair of the opposite sides of the quadrilateral are parallel and congruent, then this must be a parallelogram. Because basically what's happening is, hey, we have this right here, and we're saying, hey, we're only going to go like 10 feet this way. And this is 10 feet this way, and it goes 10 feet this way. Then these have to be the same size as each other for it to to match up. So technically, we know that those are going to be congruent with each other, those opposite sides. But this would be a quadrilateral as well, or a parallelogram as well. All right, so let's go on. Identify the parallelograms. All right, figure 1. All right, well, this is a parallelogram. I'm going to type it out. Get out of here. This is a parallelogram because the opposite angles are congruent. So angle E is congruent to angle G. Angle H is congruent to angle F. Okay, figure 2. So I'd say figure number 2 is not a parallelogram because the diagonals do not bisect each other. Look at that. HF, it's 3.6 and 3.8. If it was really bisecting each other, it would be 3.7, 3.7. And that E to G right there, it's 5.2 and 5.3. That's not congruent. They're not equal in value. All right, let's go on. Use parallelograms to find values. So the top of this eraser appears to be a parallelogram. Okay, well, what about it? Find the values of x and y so that the side of the eraser is a parallelogram. Oh, okay, so it's saying that they're a parallelogram. All right, so anyways, so I know these opposite sides, right, opposite angles are going to be congruent. So I'm going to say 56 is equal to 7x. All right, 56 degrees equals 7x. Well, 7x degrees. Let's erase that. All right, well, what's the opposite of times 7? That'd be divide by 7. So we're going to use the division property of equality. And 56 divided by 8 is 7 is 8. So 8 equals x. Okay, find the values of x. Okay, done. Now the next one right here, we would understand that this is congruent with that because they are opposite angles. So I know that 5y minus 26 degrees is equal to 4y plus 4 degrees. I'm going to subtract by 4y on both sides using the subtraction property of equality. And I get y minus 26 is equal to 4. I'm not solving for y minus 26, I'm solving for y. So I'm going to plus 26 because the opposite of minus 26 is plus 26 to both sides. And I get y is equal to 30. All right, well, if this is a parallelogram, then these angles must be true. 8 is equal to x, and y is equal to 30. That's it. We're done. Let's go on. Oh no, identify the parallelograms on a coordinate plane. Well, slopes. Now, a parallelogram, first thing we have to do is, hey, they need to have the same slope. So if I was to figure out the slope of this one, I would say A to B. It goes down 1 over 1, 2, 3, 4, 5. So down 1 over 5. So the slope of AB slope is equal to negative 1 over 5. Now that has to be equal to this one. D is down 1, 1, 2, 3, 4, 5. Okay, cool. So DC, the slope of DC is equal to down 1 over 5. Okay, so the slopes have the same value. That means they are parallel. Now let's do AD and BC right here. This goes up 1, 2, 3, and goes over 2. So DA slope is equal to 3 over 2. And 1, 2, 3 over 2. Hey, CB slope is equal to 3 halves. So I know that every opposite side of this is parallel. So at the moment, I know that this is a parallelogram. Done. But wait, there's more. Maybe we want to talk a bit about the midpoint formula. All right, well, let's hold up. So here is the midpoint formula. I like to think of it this way. You take your money, and you take your friend's money, and you add it up and divide by 2. That's pretty much, you're evening it out. You're saying, all right, your money plus my money divided by 2. Half of all our money is mine, half of all your money is you. So basically what we're going to do is we're going to figure out, all right, what's the midpoint of DB and AC? All right, well, D. Going from D to B. D, let's write it out. All right, so here are the values of DB, A, and C. So we're going to figure out the midpoint of DB and the midpoint of AC. So the midpoint of DB would be 1 plus 8 divided by 2. And then 0 plus 2 divided by 2. And the midpoint of AC would be 3 plus 6, the x's, divided by 2. And then the y's divided by 2. So if we do this, 1 plus 8 is 9. 9 divided by 2 is 4.5. Okay, so not a nice number, but that's okay. And then 2 divided by 2 is 1. All right, cool. The midpoint of AC would be 3 plus 6 is 9. 9 divided by 2 is 4.5. Just have to test this. 3 minus 1 is 2. 2 divided by 2 is 1. Well, by Jove, we just proved that the midpoints of the diagonals are the same. These diagonals bisect each other, and that's it. All right, guys. Thank you very much. I'll catch you guys in class. You guys have a wonderful day. Bye.